This is a short module on the concept. Visit mockat.com to access the complete concept video, practice questions, quiz of the day and other free resources to start your prep right away.
Now we shall look at comparing indices, right? So we'll start with the case where in both the indices or two or more indices are going to have integers in their powers, right? So the indices are integers. So let us say we have 2 power 200 and let's say 5 power 100, and you're asked to find as to which of these are greater, right? So how do we go about doing this? Now, would you lean towards the one with the higher power or the one with the higher base, right? So we don't know, right? So we're not comfortable with these. And these are very big powers, right? So what you can do over here in these cases is apply the same nth root, right? Nth root. Or nth root is nothing but raise it to the power of some fraction over here so that, this integer part can be simplified, can be reduced. You can divide by the same number. So what is the largest number which will perfectly divide both these numbers, 200 and 100? It's nothing but the HCF of these two, which is 100 itself, right? So divide both the powers by the same number. Then what do we get? We get 2 square over here and 5 over here. Now it's easy, right? So we have 4 on one side and 5 on one side. We know 5 is greater than 4. Therefore, 5 is greater than 2 square. If you raise both to the power of 100, the inequality will remain the same. 5 power 100 is going to be greater than 2 power 200. Now let's take up two more, right? So powers. 2 power 111 over here, and let's say 7 power 37, right? So which is larger over here? 37 into 3 is 111, right? So the HCF of these two is 37. By now you should have realized we need to take the HCF of all of these to make it comparable and divide each of the powers by the HCF, the same HCF, and we get 2 cube here and 7 power 1 here, which is 8 and 7. 8 is greater than 7, 2 cube is greater than 7. Therefore, this to the power of 37, 2 power 111, right, is going to be greater than 7 power 37. Now, let's look at this with an example, right? So, what do we have here? Which of the following has the largest value? 2 power 96, I'll just restate them here. 3 power 72, 5 power 48, and 23 to the power of 24. These are very, very big powers. I have to reduce them. To reduce them, I can divide all these powers by the same number, right? Now, what is the largest such number I can divide all these powers by such that I'm going to get integers as the powers? It's going to be the highest common factor of all of these four numbers. And what do we see here? 24 into 2 is 48, 24 into 3 is 72, 24 into 4 is 96. So 24 itself is the highest common factor. I can divide each of these powers by 24 and see as to what I get. And I get over here 2 power 96 by 24, which is 4. Here I get 3 power 3. Here we get 5 square. And here it's 23 power 1. So 2 power 4 is 16. 3 cube is 27. 5 square is 25. And 23 power 1 is 23. What is the largest of these? This is easy to find. It's 27. So therefore 3 power 72. Right? So that over here has the largest value amongst these. Now, how do we compare and find out which indices are bigger or smaller when it comes to fractions being the indices, right? So here, it works the other way around. So let's take up two numbers. Let's say 5 power half and 10 power 1 by 3 over here, right? Which is the bigger number over here, right? So how do we find that? Now, in the earlier case, we had integers. So it was simple, we had to divide. Now here we have a denominator. Roots and all are difficult, right? To get rid of this denominator, we have to multiply this power with some number such that the denominator disappears, right? So what number can I multiply for both, right? Or rather raise them to, the power I need to raise them to in both cases, such that both these denominators disappear. So that's going to be the LCM of 2 and 3. What's the LCM of 2 and 3? It's 6. I can raise both of them to the power of 6, right? So and what happens over here? I get a half into 6 is 3. 1/3 of 6 is 2, so I get 10 square. This is 125 and this is 100. 125 is greater than 100, and therefore 5 power half or root of 5 is greater than cube root of 10. So let's look at it with an example over here, right? So which of the following has the largest value? 2 power 1 by 8, 3 power 1 by 12, 5 power 1 by 16, and 6 power 1 by 24. Right, so how do we work with this? I told you we need to get rid of all the denominators. So I need to find the LCM of all the denominators over here, which is 8, 12, 16, 24. LCM of 12 and 24 is 24 itself, so I can forget it. We've seen this before. 8 and 16, it's 16. So the smaller number I can ignore. Between 16 and 24, what's the LCM going to be? 24 2s are 48, right? Next multiple of 24 is 48. And 16 3s are 48 also, right? So therefore, this is the LCM here, right? Else you can do the common division method and try to find out. It's just going to be a little time consuming. Small numbers, try to quickly get this LCM by observing multiples like what I did now. Now that we found the LCM of all the denominators, I have to raise each of these indices to the power of 48, right? If I raise all of them to the power of 48, they're still comparable. Right, the larger one will remain the largest one will remain the largest, smallest the smallest, and so on. Right, I'm raising all of them to the same power of 48. Now I can simplify. 1/8 of 48. Right, 48 by 8 is 6. So this 2 power 6. This is 3 power 4. 48 by 16 is 3. So 5 cube here and 6 square. Right, 6 square. 2 power 6 over here is 64. 3 power 4 is 81. Knowing the powers will be helpful. 125. Number theory lesson. We have a list of powers, right? Please make sure you memorize them. We need to find the largest value. The largest over here is 125, right? So this upwards 5 power 1 by 16. Option 3 over here has the largest value amongst these. Now let's look at a couple of practice questions in indices, right? Example 9. If 7 power x plus 1 equals 49 power y, and 27 power x equals 81 power y into 27, then what is this equal to, right? 2 power x minus y. Now, the variables are sitting in the exponents, right? Not in the bases. But what do we see with the bases over here? Here we have 7, here we have 49. 49 is nothing but 7 square, right? So we can write this as 7 power x plus 1 equals 7 square whole power y, right? So 49 power y is 7 square whole power y, which is nothing but 7 power x plus 1 equals 7 power 2y. When the bases are the same, the powers over here, the indices, the exponents, they also have to be equal, right? So x plus 1 should be equal to 2y, right? So that's the first equation which we get. Now for the second one, 27 power x, 81 here and 27, all of them are powers of 3, right? So therefore, 27 power x can be written as 3 cube whole power x. Going forward, you have to directly write this as 3 power 3x, right? For now, I'll write it this way, 3 power 4 whole power y with the step into 3 cube. And what do we get here? 3 power 4y into 3 cube is nothing but 3 power 4y plus 3, right? If you're multiplying with the same base, you can add up the powers, right? So this is going to be 3 power 4y plus 3. The bases are the same, right? 3 and 3. So therefore, the powers should be equal as well. 3x equals 4y plus 3. That's the second equation we get. Now I need to solve for x and y and substitute into this to find the answer. How do we do that? So we have equation 1 and equation 2 over here. Twice this is going to give me 4y, alright? So equation 1 into 2, multiply this with 2, we're going to get 2x plus 2 equals 4y. Now we can subtract these two, right? Top minus bottom, 3x minus 2x is x, minus 2 equals 3, which means x equals 5. Now if x equals 5 is going to be plugged into this, we get 2y equals 6, which means y equals 3. Y equals 3 and x equals 5. We need to find 2 power x minus y, which is nothing but 5 minus 3, right? So that is what we need to find. 2 power x minus y equals 2 power 5 minus 3, which is 2 square, which equals 4. Option 2 over here is the correct answer. On to example 10, right? So looks like a difficult one, but what do we notice over here? All the bases are same, they're all x, right? Answer options are all x power something, okay? So how do we simplify the first one? X power a divided by x power b minus c, right? Where the bases are the same, then the exponents can be subtracted. So I'm going to get x power a minus of b minus c. That's my first. Next, into x bar. What do we get here? B minus of C minus A, alright, whole power 2 into x bar C minus of A minus B, and I raise this to the power of 3. And what do we get here? This is going to be x bar A minus B plus C into x bar. 2 has to be multiplied over here with each of them. So 2B minus 2C plus 2A, right? Minus of minus A is plus A into x to the power of 3C minus 3A plus 3B. Now, as the bases are the same and I'm multiplying all of them, what can be done is I can add all of these parts over here, right? And express it as x bar, the sum of all these parts. Now, let's find out all the A terms. A plus 2A minus 3A, right? 3A minus 3A is 0 for A. Now, for B, it's minus B plus 2B, right? Minus B plus 2B is B itself. B plus 3B is plus 4B. And what about C over here? C minus 2C is minus C, and then a plus 2C, right? So this is what we get. It's x bar 4B plus 2C. Where do we have it? We have it in option 2 over here, and that's the answer here.
If you found this video useful, please like and share it. Subscribe to the channel and let us know what you'd like to watch next in the comments below. Don't forget to visit mockcat.com to access free resources to get through your Dream B School.